Now that our interpreter has continuations, we can do much more with control flow. For one thing, we can take control of exceptions. Currently, when the interpreter raises an exception, like when we apply a number as if it was a function, we use Splait's exception mechanism to raise the error. What we can do instead is have our interpreter return an error value and then decide what to do directly inside the interpreter. To see how this would work, let's take a closer look at the application case in the interpreter. Whereas before we would raise a Shplait exception using the error function, now we'll return an error value, and that'll be a new kind of value inside of our interpreter. And then the key that will make this all work is when we return an error v, we drop the continuation k. So instead of continuing along that path and finishing the program, we just stop where we are and immediately return an error. Let's go and implement it. Here we have the lambda k interpreter. First thing we need to do is extend our values. Error v takes in a string message. Next up, wherever our interpreter would use Shplait to raise an exception, will now return an error v value. We can keep this error here. So this is inside the parser. That'll still depend on Shplait to raise an error. Okay, and here's the first case down below. So for applications, we were raising an error before. Now we'll return error v. Okay, num up, we want an error v. And lookup, error v. And let's just say free variable. Okay, because also we need to change our tests. So whereas before we would depend on Shplait, we would use a check raises. Now that we're returning an error v value, we could just say check is. So now we need to go up and change all those tests. And I think with that, we should be all set. Let's run. Check failed. Okay, we'll come back to this check in just a minute. So except for that one, we're all set. Let's run a quick test. So this program is just a free variable. So we should get an error v value when we run it that says free variable. We need to supply a continuation. Okay, and that check works. But now let's modify it slightly. Let's do 1 plus x instead. So we should still get an error v free variable as the result. But oh no, we don't get that. So instead of error v free variable, we're getting error v not a number. What's going on? Well, we know from the first test that when our interpreter encounters a free variable, it gives us an error v value, free variable. So that's what's happening here inside the plus. When we interpret x, we do get that error v free variable value. But then instead of stopping, the interpreter moves on. It continues along the continuation, tries to do a plus, and then it sees, oh no, I'm adding 1 to an error v value. I need to give an error. That's not a number, that's an error v. In order to fix this, we need to go back and modify our helper functions. So anytime a helper might fail, we need to extend it to take in a continuation, and then it can decide either to continue or to stop. So here in the interpreter right now, what we have for the ID case is that we always continue, and then we call the lookup helper function. What we need to do instead is let lookup decide whether or not to continue. So we'll pass that continuation along the lookup function. Then we need to modify that, so let's jump to the definition. Lookup should take a symbol, an environment, and a continuation K. And now in the error case, we just return error V. And when we succeed, we continue. And with that, we should be all set. Uh-oh, we've got to change our tests for lookup. So these all need continuation. Okay, now we did it. So our two checks now are passing. Let's do a third check. So if we remove the unbound variable and we instead add a number to a function, we should get an error here that says not a number. Great. Now what if we use this expression? So let's take that 1 plus funxx, which we know should give us a not a number error, and let's apply that as if it were a function. So what we should get from interpreting this is still not a number. Uh-oh, we've got an error. And what's going wrong here is exactly what went wrong in our previous test. Before, the problem was that lookup was continuing no matter what. So even when it had an error V, it was going forward with the continuation. We modified lookup and stopped it from doing that. We didn't modify plus yet, though. So plus and multiplication, any numeric operation, these are things that can fail. And when they fail, they need to stop going forward on the continuation. Let's go back up to the interpreter and change the calls to the helper functions. Inside interp, we have no helper calls. But inside continue, when we do plus k, we need to change this so that num plus takes into continuation. So now num plus can decide whether or not to use that continuation. And same thing for multiplication. Okay, and now we need to change our helpers. Plus takes a k. Mult takes a k. And they can just pass that along to the numop helper. Now when the numop succeeds, it should continue. And when it fails, it can just return an error V, all set. So the last thing we need to do is extend our tests. They need a continuation argument. And we can add one test while we're here. So nummult, we try to multiply a number with something that's not a number, that should give us an error V. Excellent, test pass. Now let's come back to the test that we commented out. We hid this check before because it was giving us an error. The interpreter was returning something that was not an error V free variable. And now that we've worked through these simpler tests, it's easy to see what was happening down below. The free variable is this y here, so that was creating an error v value when the function got called. But before we went back and modified our helper functions, that error v value was getting returned as the result of evaluating y. So then it went into addition, and then our num op raised the not a number error. Now, to summarize, what we did to implement errors was to go through our interpreter, introduce an error v value, return error v instead of calling Splait's error function, and then modify every helper function that might fail to now take in a continuation as input. And then in the error case, it was free to ignore the continuation. And in the non-error case, we could use that continuation to go forward. We made this change to lookup and also to num op.